Hi guys, good morning. Since new normal naman ta karon, so magklase ta ara sa YouTube. My first video tutorial is about relations and functions. So, if you have questions, just comment down below. I will try to answer those questions in my next video, in my next video tutorial. I will try my best to answer your questions. Then, don't forget to subscribe and share to your friends, follow. Para sa akong mga estudyante, na ako yung mga ipang-send ninyo mga exercises, then you can refer to the video nga akong i-upload sa YouTube. Daghan ko mga video soon. Then for those of you nga wala yung mga gadgets, so pwede ra ko magpa-send ninyo og mga modules. Yan nasa mo yung mga pangansiran. So do not forget to subscribe below na adiha, then click that bell aron notify mo kung na mga bagong video. So hopefully na may makatunan sa akong mga tutorials. Thank you and good day. Okay, good morning guys. For today's video, we will have relations and functions. The difference between relations and functions. Uh, for the competency, you are you should be able to represent real life situations using functions, including piecewise functions. For the sub-competency, you will have to define what is a relation and what is a function. You will also be able to differentiate relations from functions, identify relations and functions, and the most important thing is you will be able uh, to relate relations and functions in real life situations. Okay, so to start, we'll have to review first. As a review, we'll go back to the definition of a relation. It says that a relation is between two variables x and y. There's a set of ordered pairs. An ordered pair consists of an x and y coordinates. Later, I will be showing you an example of an ordered pair. A relation can be represented using an ordered pair, as I've said, it's the basic. A relation can also be represented using mapping design. It can also be represented using table or table of values. We can also represent relation using equations, using graph, or sentences. Again, later I will be presenting to you examples of how to present relations. An ordered pair or a relation, as I've said earlier, is consist of an x and y coordinates. The x value in the coordinate can be named as inputs, domains, independent variable. The most common name for x values or the first coordinates in a relation is domain. But sometimes we will also be using inputs and independent variable. While on the other hand, the y values are named as outputs, range, or dependent variable. Or the most common name is range. Now, another review. This is an example. The first example uh, is an example of an ordered pair. We have there 2, 0, -1, and -18. All of these are examples of relation. Okay, so this is what I mentioned earlier that an ordered pair consists of two values, the x coordinates and the y coordinates. So the first value in an ordered pair is what we call an input, the domain, or independent variable. While the second number in the while the second number in an ordered pair or in a coordinate is what we call an output, an ordered an output, range, or a dependent variable. So the same also with the second example, with the second ordered pair. We have -1 and -18. Next is an example of an a relation being represented in table of values. So we have here the x coordinate or the y coordinates. Okay, this can also be represented in vertical form, but in this case, this is in horizontal form. So we have here the x coordinates are -2, 4, and 6. So these are what we call the domain, and these are what we call the range. The second coordinate is what we call the range. So we have this ordered pair is -2 and 3, 4 and -1, 6 and 4. Another representation for table of values is what, as I've said, mapping design. So the first, this map is consist of the independent variable and the dependent variable. The first mapping here, we have -1 is paired to +1, +1 is paired to +1, +7 is paired to +49, and +5 is paired, and +0.5 is paired to +0.25. So these are just some of the examples on how to represent a relation. Next, example 1. So we have here a set of all ordered pairs. We have 1, 0, -5, 1, -4, 2, -3, 3, -2, 4, -1, and 5 and 0. So we have 1, 2, 3, 4, 5, 6. We have 6 coordinates. We have one set of 6 coordinates here. Now, question, which which of these numbers first coordinates is called the domain, and which of these numbers are called the range? So what is the domain and what is the range? So as I've said earlier, the input, the domain, and the independent variable are the set of all first coordinates in an ordered pair, while the range are the output, the range, or the dependent variable is what are the set of second coordinates in an ordered pair. So in this example, our domains are 0, 1, 2, 3, 4, and 5. As you can see in the arrow. So, kana sila tanan, mauna sila yung domain. While the range are, we have -5, -4, -3, -2, -1, and 0. So, given a set of ordered pairs, we can identify the domain and the range in a relation. Next, example number 2. In this case, we are given an example of a mapping. So this is another example of a mapping. So in this case, we also have the input and the output. So these are the domain and these are the range, the independent variable and the dependent variable. In this case, for the input, we have 4, -5, 0, 9, and -1. As you can see, each of these inputs are paired to only two numbers in the output, which are the range. Say, for example, 4 is paired to -2, -5 is paired to -2, 0 is paired also to -2. At the same time, 0 is paired to 7, 9 is paired to 7, and -1 is paired to 7. So which of these examples, which of these two set of values are domain and range? So in this example, our domain, as I've said, the input are 4, -5, 0, 9, and -1, while the output are -2 and 7. Okay, now, question, is a relation are functions? So what is therefore the difference between a relation and a function? As I've said, I'll go back to the definition of a relation. A relation are a set of ordered pairs, meaning there's no restriction. as long as it is a set of the domain and range. So what is therefore a function? A function is also a relation. So meaning, a function is a relation in which there is a restriction. And every input is paired with only one output. Meaning, every element in the domain be should always have one pair in the range. Meaning, ang function relation gyapon siya pero ang iyang domain kinahanglan usa ra ang iyang pares sa range. That's it. So kung ato nang kung atong i-relate sa relasyon, hugot sa ta. Kung atong i-relate sa relasyon, ang relasyon mo function ra na siya kung usa ra ang imong pares. Dili pwede ikaw duha imong uyab, dili pwede ikaw usa duha ang imong asawa. So meaning, a function is a relation kapon siya, but there should always be one pair in the range. Okay? So, other than that, dili siya function, mere relation ra siya. Okay? We'll take this example. Let's focus on the x-coordinates when given a relation. Okay, the set of ordered pairs have different x-coordinates. It is a function, lain-laing x-coordinates. If the set of ordered pairs have the same x-coordinates given only once bisag usa ra, it is not a function. Meaning, kung ang imong x-coordinate na ay usa ka x-coordinate na ay duha ka pares sa y-coordinate, so dili na siya function. Okay, example 3. We will take this for example. So we have here set of coordinates negative 0, negative 5, 1, negative 4, 2, negative 3, 3, negative 2, 4, negative 1, and 5, and 0. Now take a look at the x-coordinates. So the x-coordinates are, or the domains are 0, 1, 2, 3, 4, and 5. So try to look at the domains kung naabay nagbalik-balik. So 0, 1, 2, 3, 4, and 5. Meaning, kay wa may nagbalik-balik. Therefore, this set of ordered pairs, this relation is a function. Okay. So meaning, dili ra siya ma-function kung naay magbalik-balik. Let's take for example, by the way, the second coordinate has no bearing. Bahala nagnay magbalik-balik sa second coordinate basta ang sa first coordinate wala magbalik. So example 4. So negative 1, negative 7, negative 1, negative 7, 1, 0, 2, negative 3, 0, negative 8, 0, 5, negative 2, negative 1. So, pangutana, is this a function? Again, take a look at the first coordinates. Again, as I told you, the second coordinates has no bearing. So, meaning, bahala nagkapila na magbalik ang sa second coordinate basta ang first coordinate walay magbalik. So, the first coordinate, negative 1, positive 1, positive 2, 0, 0, negative 2. So, as you can see, 0 is being repeated. Kaduha. So, as I've said, kausara na siya dapat. So, kaduha, katulog, kaupat, and so on, dili na siya function. So, if the question is, this is a function, meaning this is not a function. No, this is not a function. Again, kinahanglan walay magbalik sa first coordinate. Okay rang na magbalik sa second coordinates. Now, let's take this example. In this case, we have the mapping. The function is being represented. The relation is being represented by a mapping. So we have here two choices. The first choice, we have the domain, and the first choice is 3, 1, 0. The second choice is negative 1, 2, and 3. In choice 2, In choice 2, we have 2, negative 1, 3, and 2, 3, negative 2, and 0. All we need to do, if you're given a mapping, all you need to do is the arrow. Kung asa ka, kung kapila siya na pair. But again, you focus your attention on the first coordinates. And in the first, in the domain or in the input, we have the input here, 3, 1, 0. 3 is paired to negative 1, 1 is paired to 2, 0 is paired to 2. As you can see, ari rata mag-focus diri sa independent variable or the input. This is the input, this is the output. So, try to check, even if 1 is paired to 2 and 0 is paired to 2, since 1 and 2 is paired only once, pero ngadto ra sa 2. So, meaning, this choice is a function. Choice 1 is a function. While choice 2, try to look at the choice 2. 2, negative 1, and 3. In this example, we have 2 is paired to 2, negative 1 is paired to 3, at the same time, negative 1 is paired to negative 2, 3 is paired to 0. So, try to focus your attention on negative 1. The negative 1 is paired twice to the range. So, the domain, negative 1 is paired twice. So, negative 1 is paired to 3, negative 1 is paired to negative 2. So, if we are going to answer which of these choices is a function, meaning choice 1 is a function, while choice 2 is not a function. But the question is, are these two choices a relation? Yes, these are relation, because the definition of a relation is set of ordered pairs. There's no restriction. While in a function, the restriction is kinahanglan usara ang iyang domain o usara ma-pair sa range. Okay. Next, the same mapping Japon. We have here A and B. In the domain, we only have two. In the range, we have A, B, and C. In this part here, the B, in sa B, we have the domain A, B, C. Now, which of these two are function? Try to observe letter A. There's only one element in the domain, which is 2. 2 is paired to A, 2 is paired to B, 2 is paired to C. So, 2 is paired thrice, katulo. While sa B, A is paired to 2, B is paired to 2, and C is paired to 2. So, each of the element in the domain is only paired once to the range, even if ang range is kausaran abo. So, which of these two examples is a function? So, the answer is letter B. Okay, next. Which of these situations represent a function? So, arita sa sentence. A. The items in a store to their prices in a certain date. B. Types of fruits to their colors. If you have observed the items in a store sa tindahan, ito ka sa supermarket, each item in the supermarket has only one price. Dili pwede ang apple, the same klaseng apple, ang usa G's, ang usa 20 the same klase. So, kinahanglan ang taga-usa ka item sa store na agyo na siya usa price. While sa letter B, sa types of fruits to the colors, we can say, let's go back to the apple. Natay apple, usa ka klase nga apple, pero lain-lain of colors. Nay apple nga kuha, nay apple nga green. Say for example, sa grapes. Nay grapes nga kuha, nay grapes nga green. Naay grapes nga seedless, nasa grapes nga naay liso. Okay, so in this example, letter A is a function. Okay, letter A is a function. Okay, usa-usa ra man na ang kapresyo sa usa ka item sa grocery store. Mabitaw na inig panso diha, usa-usahon jud og panso kay lain man sila presyo. Okay. Now, the vertical line test. How to use the vertical line test? The vertical line test is only used if the given relation is a graph. So if you are going to identify if a graph is a relation or a function. So ano sa amon ta magkamit sa vertical line test? Gamiton ra ang vertical line test kung ang given is a graph. So how to use the vertical line test? By the name vertical, so meaning from top to bottom or bottom to top or kasagaran top to bottom. Okay? So is vertical line is vertical line drawn through its graph passes through only one point. Meaning, kung ang in-draw nimo sa vertical line, in-draw nimo for example this graph, okay, the graph, this line, this pink line. In-draw nimo sa vertical line is up, down. So in-draw nimo sa vertical line, mo cross gani siya sa graph only once. Bisag asa ka diha mo draw vertical line, will cross the graph only once. That means it is a function. So it is very clear with this line here, using a vertical line test, if we are going to draw one line, vertical line through this graph, it will always pass through the graph once. Meaning kausabi sa asa ka ana niya mo draw vertical line kausara na siya. So meaning this is a function. Okay, another example. Now, to this graph be a function. So klaro kaayo when you it's very clear that when you draw a vertical line through this graph, the vertical line will cross the graph at 2 points. First point here, the second point here, or bisag asa the first point, second point. So let's say for example, kausa diha, but pag abot diri dapita, kaduha. Pag abot pag yun diri dapita, bisag asa ka ani diri dapita, kaduha gyapon. So therefore this graph is not a function. Okay. Now, given the same gyapon given a graph, but in this case, let's identify the graph as continuous or discrete. When we say continuous, when we say continuous graph, the domain are all real numbers, meaning that includes fractions, everything. Okay. When I say discrete, the domain are integers, meaning integers, signed numbers. So there are only two things that you need to remember: discrete and continuous. It will be easy for you to identify a graph which is discrete and continuous if the, if the graph is not connected, meaning uh, there's no line, there are only points there. It is discrete. While if the graph is connected, it is uh, continuous. For example, here, what kind of graph is this? What kind of range is this? So, is the following function discrete or continuous? What is the domain and what is the range? So we have here 1, 2, 3, 4, 5, 6. So these are functions, right? 1, 2, 3, 4, 5, 6. Because in each coordinate, we only have one. In each coordinate, we only have one x values here. So this is an example of a discrete function. The domains are -7 here is 1, -7, +1, +5, uh, +7, +8, and +10. So for the domain, ang inyong tan-awon is kinirang x. This is the x-axis, the x coordinates, and these are the y. This is the y coordinates. So these are the values in the y-axis or the range. So atong tan-awon for the domain is kinira. So we have tan-awon mo ni ang ordered pair ani will be -7 and positive kini. -7 and +1. So meaning the domain is -7, the range is +1. Here, the domain is the domain is +1 at the same time the range is +1. Here, the domain is positive 5, but at the same time, the range is negative 7. Here, the domain is positive 7, but the range is positive 5. Here, the domain is positive 8 and the range is positive 2. Here, the domain is positive 10, the range is positive 8. Okay, next example. Here, what type of a function? Of course, since it is connected, meaning the domain takes all of real numbers. So this is continuous. Now, the domain will start since continuous man na siya. So, atong i-write ang iyang domain in uh, sa pangalan ni um, yan, nakalimot ko sa pangalan. Okay, we'll start from negative. The domain starts from negative 8 to positive 8. So, tanaw mo ang iyang at both ends. So, from negative 8 to positive 8. Why? Because it stops here. So, negative 8 to positive 8. While the range, it starts from it starts from negative 6 to positive 6. So if you are going to identify the domain, you start from left to right, while the range you start from bottom up. Okay, so the domain is from negative 8 to positive 8, while the range is negative 7 to negative 6 to positive 6. Here, this is continuous. The domain would start from, since this is the x-axis here and this is the y-axis, so the domain starts from 0 to positive 40. From 0, it starts here from 0 to positive 45. That is our domain. Whereas the range starts from 7 to from 10 to 70. Okay, here in this example, this is an example of discrete function and the domain R. So we cannot use the okay. So this we will have, for this example, we will have to list down all the domains here. So in this case, negative 7, negative 5, negative 3, negative 1, positive 1, positive 3, positive 5, and positive 7. So this case meaning negative 4, negative 4 is not part of the domain. So wala siya diha. While the range, negative 4, yung example diri, kanini nga negative 4, kanini negative 6, wala sila, kanini negative 2, wala na sila sa domain, kanini positive 2, positive 4, wala na sila sa domain. For the range, we start with gamitan ang dira. So, positive 3, positive 2, positive 3, positive 4, kini nga linya, positive 5, and positive 7. So, asa ito mga natungnan sa points. Next. Okay, domain and range in real life. Okay, let's try for example, moving na sa real life situation. The number of shoes in X pairs of shoes can be expressed by the equation y equals 2x. So, what is a subset of real numbers makes sense of the domain? Okay, in this case, whole numbers. Ano man whole numbers? Because wala may pair nga katong pair gani one pair duha ka shoes. So dili, for example, usa ra ka shoes, dili na siya pair. So meaning one pair, two pairs, dili on 1.5 pairs, dili no. So meaning whole numbers siya. Whereas what would make sense for the range of the function? In this case, 0 and even numbers. Kung wala, so wala. Kung naay usa ka pair, so pila ka shoes. Kung naay duha ka pair, pila ka shoes. So if there is only one pair, there are two number of shoes. So this function, the independent variable is the number of pairs of shoes, while the dependent variable would be the total number of shoes. So for example, uh, there are 6 pairs of shoes, so meaning the total number of shoes is 12. If there are 10 pairs of shoes, the total number of shoes will be 20. Say the independent variable is the pairs of shoes, the number of the pairs of shoes, while the dependent variable is the total number of shoes. Next, we'll try this example. Real life situations. Mr. Friel is driving to his hometown in Oslo. It takes 4 hours to get there. The distance he travels at any time t is represented by the function d equals 55t. His average speed is 55 kph, meaning the distance traveled and the time it takes to travel to his hometown. A question: what is the independent variable? The time of travel, meaning the distance is the dependent variable. The distance traveled is tra- dependent on the traveling time. So if the traveling time is 1 hour, meaning the distance traveled is shorter than if you are to travel 2 hours. So meaning the traveling time is the independent variable, while the distance being traveled is the dependent variable. Okay, another example. Johnny bought at post 10 tickets to a concert for him and his friends. The cost of each ticket was 12 pesos. Complete the table below to list the possible domain and range. So in this case, what is the dependent variable? Of course, it is the number of tickets bought. And the dependent variable is the price of the tickets. So kung pila imong ticket palit ang magdepende ang imong bayaran kung pila ka book ticket imong paliton. So for example, if you will only buy one ticket, since each ticket costs 12.50, so if you will only buy one ticket, you will only pay 12.50. If you will buy two tickets, you will pay 25 pesos. If you will buy three tickets, you will pay 37.50, and so on. So since there are 10 tickets sold, so meaning pila ang nabayaran ni Johnny? That's 125. So this is an example of table of values. The number of tickets, which is the domain or the independent variable, and the price of the tickets, which is the range or the dependent variable. So the independent variable is the number of tickets booked, and the dependent variable are the total cost of the ticket.